For as long as you have studied science, I'm sure that the word you have probably heard the most is the word energy. Energy is definitely the central property in thermodynamics, as was apparent when we discussed heat engines and biological cells. In chemistry and biochemistry, energy comes into play when we discuss how much energy can be released as heat or work as a result of a chemical reaction. For instance, on the diagram below, we show the evolution of energy along the pathway from reactants and products. We can clearly see that the reactants have a higher energy level than the products, and that chemical energy will be released as a result of reorganization of chemical bonds during the chemical reaction. However, we also see on this diagram that for the reaction to take place, some energy, typically thermal energy, must be transferred to the reactants so they can cross the energy barrier separating them from the products. Using the chemical language, we say that a chemical reaction is thermally activated, or that a reaction exhibits an activation energy. This activation energy is, of course, the difference between the energy associated with the system at the top of the barrier and the energy of the reactants. We've learned when we studied the kinetics of chemical reactions in general chemistry and in subsequent courses that the rate of a chemical reaction and the change of this rate with temperature depends very strongly on the activation energy. We've also learned that we can use enzymes or catalysts to increase the rate of chemical reactions. We've learned also that enzymes or catalysts do not change the energy levels of the reactants or the products, but that they simply lower the activation energy for the chemical reaction, hence making it more likely that a given chemical reaction can take place at a given temperature. So, energy is indeed the central property in chemistry and biochemistry. It is the change in this property between products and reactants that tells us how much work and heat can be produced as a result of that reaction. And it is the property that we must focus on to understand the time scale over which chemical reactions occur.